Good morning, all. In today's class, we are going to see the basic parameters associated with the electricity. The fundamental parameter associated with the electricity is nothing but electric charge. The electric charge is defined as it is the property of a matter that exists because of excess or a deficiency of electrons. When you have a deficiency in electrons, then we say that the property or the material is positively charged. When you're having an excess electron, when you're having an excess electron, you will call it as positively charged. So depending upon the excess or deficiency of the electrons, the charges will be classified into two types. One is a positive charge and another one is a negative charge. And we know that the like charges will repel each other and the unlike charges attract each other. That means if you're having positive and positive charge, there are two positive charges, then it will repel each other. If you're having positive and negative charge, it will attract each other. And here the electric charge may be quantized. So here when we are talking about charge, for electron, one electron will be equal to 1.602 into 10 power minus 19 coulomb. This is charge of one electron. The SI unit of electric charge is nothing but coulomb. The fundamental equation for charge is nothing but I into T. I into T. Next one, electric current. It is defined as the rate of change of charge. That is, it is represented by dq by dt. The unit of electric current is nothing but ampere and it is represented by 1 coulomb per second. It is represented by 1 coulomb per second. We know that depending upon the supply, there are two types of currents are available. One is an alternating current and another one is nothing but direct current. When we say the current is alternating in nature, then the amplitude changes continuously with respect to time. That's why we are calling it as alternating current. When we say the current is a DC current, it will have a steady current value. You will have a steady current value. That's why we are calling it as DC current. And when you're representing the current value in a circuit, we will represent it with by two indicators. One is nothing but the direction, another one is nothing but magnitude. So always when you're representing the current, the direction is very important and also you have to represent the value of magnitude. So for example, here the current direction is from A to E. So A to B. So it is plus 5 ampere. Here B to A. That's why it is minus 5 ampere. In the case of AC currents, the magnitude varies with respect to time. In the case of DC currents, it will have a steady state value. Next one, electric voltage. So it's nothing but you have to do some energy or otherwise you have to do some work if you want to move the charge from the point A to B. So the work done on moving a charge from point A to B is called as voltage. Or otherwise the potential difference between two points can also be named as electric voltage. The unit of electric voltage is nothing but volt. So 1 volt will be equal to 1 joule per 1 coulomb. We know the basic equation, that is nothing but dW divided by dQ. So dW is nothing but work done and dQ is nothing but charge. That's why we have got the unit as joule per coulomb. So see here also you will have a positive voltage or negative voltage. If A is higher potential with respect to B, then we say it's a positive potential, higher potential. If A is lower potential with respect to B, then we say it is a negative potential. It is a lower potential. It is represented by minus P and here it is represented by plus 2 voltage. Then the power. The power is nothing but rate of change of energy. Rate of change of energy is defined as power. and the symbol for power is nothing but capital P or otherwise small p. So the unit of power is nothing but 1 watt. So 1 watt equal to 1 joule per 1 coulomb, 1 second. So in you're having an AC circuit, when you're having an AC circuit, the power is nothing but the voltage multiply it with current. But here it is represented by V of t. It is nothing but instantaneous value of voltage. And here we have got I of t, instantaneous value of current. Why we are mentioning it as instantaneous value of voltage and instantaneous value of current is nothing but the value of voltage and current is continuously changing with respect to time. That's why we are mentioning it as instantaneous value. But in the case of DC circuit, it is nothing but product of voltage into current. This is nothing but DC circuit. So, whatever the things we have discussed so far, the voltage, current, and one more thing, resistance. This can be represented by a water analogy. We have got a water tank in our home. Okay, from the water tank, the water is coming from to the pipes. Whatever may be the water stored in the tank is related to the voltage, the amount of water. And if you want to open the tap, if you're opening the tap, what will happen? The water will flow. The water flow is nothing but is related to current flow. And depending upon the pipe diameter and depending upon the pipe opening, you will have the current flow. If you are having a wide opening, then what will happen? The water flow will be more. If you are having a lesser opening, then you will have the water flow will be less. So this is called as whatever may be the opposition offered to the flow of water. Okay. Here, in the case of electric circuit, it is nothing but opposition offered to the flow of current is called as resistance. So this is what the water analogy represents. Next one, resistance. So resistance is nothing but it is represented by R and the unit of resistance is nothing but ohm. So generally resistance is nothing but it is the opposition offered to the flow of electric current. So we know that the voltage is directly proportional to current. So this can be changed into a proportionality constant, that is nothing but R into I, where R is nothing but resistance. So we know this, just keep the triangle in your mind. So V is nothing but I into R. Or otherwise I is nothing but V by R. Or otherwise R is nothing but V by I. We can represent the value of V, I and R. Okay. V is nothing but I into R. Or I is nothing but V by R. Or otherwise R is nothing but V by I. It is nothing but resistance. So it is measured in ohms. And you have got different materials. So different materials will have different resistance. For example, if you're having a metallic substances, then you will have very low resistance. The examples are nothing but silver, copper and aluminium. And you will have the materials with have moderate value of resistance. And the examples are silicon and germanium. And extreme resistance, some of the materials will offer high resistance. So that is nothing but papers. Papers, dry woods, mica, porcelain. That's why these materials are used as an insulators. This offers high value of resistance. That's why it is being used for insulation purposes. So effect on the temperature resistance. So what the temperature, depending upon the temperature, how the resistance you will have. So in the case of metallic substances, when you are increasing the resistance, when you are increasing the temperature, then the atomic vibrations will increase. So because of this, the temperature coefficient will be positive for these materials. In case of semiconductors, if you are increasing the temperature, then the number of free electrons also increases. So that's why the semiconductors are having a negative temperature coefficient. The metallic substances will have positive temperature coefficient and the semiconductors will have negative temperature coefficient. Ohm's law. So we know the basics of Ohm's law. At constant temperature, the current flowing through the conductor, is directly proportional to the potential difference between the two ends of the conductor. The current is directly proportional to the potential difference between the conductors, and it is inversely proportional to the resistance. So now this can be represented as I is nothing but V by R. So now we know the value of I. So this is a basic diagram which shows the relation between all the four parameters V, I, power and R. We know that power is nothing but V into I. Now I can replace the value of I as V by R, or otherwise I can replace I as P by V, or otherwise P is equal to I square into R. From that I can find out the value of I. So this is the basic image or otherwise diagram that represents the value of all the quantities. So P can be represented as V into I or I square R or V square by R. R is nothing but V by R or V square by P or otherwise P by I square. So this is the basic relationship between the different parameters.